Good to go.
We're good to go. Hello, everyone. Welcome back. I am pleased to bring to our broadcast stage Dr. June Andrews, Senior Director, Search Sciences at Nike. Go ahead, June.
All right, thanks so much, PJ. Thanks everyone for figuring out how do we keep investing in the ML and data science community in this remote setting. So very excited to share some thoughts I've been pulling together on some broader trends in the industry. And it's a little bit of a slippery idea. You almost want to see it in theory, which we'll share today, but also I hope this stays in the back of your mind so that when you see it in practice in your work, you can take a step back and say, we've got an opportunity here to demand more of our ML products. Okay, so this is ML in particular for human decision making. So first things first, human decisions. What are they? So these are three application areas I've worked in where you have to make you have to have a person making a decision. One is in airline maintenance for jet engines of, does the engine need maintenance? That seems like a good question to know when you're flying planes around the world. And if so, on what timeline for what is it going to need maintenance? And in that application, we were able to use the previous decisions that had been made to train an ML model and provide real-time recommendations for, do we see something here that should be acted upon? Another area I've come across ML being included in human decision-making is in the courts with the recidivism score of trying to help judges make how quickly these cases go through is a little bit mind-boggling. So they have to take a person and very quickly figure out how they're going to process them through the legal system. And ML has is attempting to get integrated in there, and depending on the state, has various forms of adoption. On the lighter-hearted end of the spectrum, I've also worked with human decision-making in fashions. When we're thinking about how do we help folks present their best selves and bring joy to the world, what are going to be the trends going forward that we should be lining up our supply chains for creating and making available for future purchases? So these are three very different areas, but oddly, three very different areas. And just calling out, just in these three areas, in the US alone, we've got 2 million folks making these decisions on the ground. And if you expand that out, there are a lot of folks that in the industrial and government settings need to be using their expertise, their understanding of the space to make decisions that help the world go round. Now, all three of these areas and several others are going to have some pressures for integrating ML into that decision making. A couple of the pressures are fatigue, decision fatigue, and the ability to make these decisions over and over is wearing. In fact, in aviation, you have an entire section of the FAA looks into fatigue and how it affects decision making and uses that to help with its regulations. You've got other pressures of, these are historical, almost old school fields in which we're seeing declining rates of folks graduating with more advanced degrees in these fields. So you've got the expertise is becoming a bit more sparse. You've got, it's just a hard job all around. And you've also got the pressures of the number of decisions these folks need to make rapidly increasing as the population grows and what we demand out of the world to increase our quality of life increases. And you've got a declining expertise base to use in those settings. The last pressure that you've got is there is a distribution of talent in these fields where there are folks that can make really high quality decisions, and spreading that expertise around these fields is very much going to beneficial to better quality decision making in critical areas. So as disparate as those areas are, the ML that I've helped integrate in them actually follows a very simple pattern. Because of the responsibility of these different areas, you're never going to break the chain of responsibility. You always want to have a process where that chain of responsibility is intact. And the chain of responsibility is something, an understanding in these fields that has been built up over hundreds of years, over thousands of special cases of understanding how should we handle this, and using that to refine these systems. So you're always going to have that backbone of the raw information is going to be available to the person at a given point in time. And ML will take the form of augmenting the human decision making by also in parallel processing that information and providing a recommendation for what the decision should be, with a little bit of explainability of why does ML think it should be this, with what confidence. And that should be taken into account. So that's the pattern across 3 very different fields. Okay, so how does that ML get developed? Currently, what happens is folks raise their hand and say, I've got this use case. Would you mind helping out with this? You go through the heavy process, as the comment person alluded earlier, of collecting all that data, being able to transcribe what's been happening in this physical world into a space and a format that computers can understand. And then you've got a crack team like Moss from IT Crowd that takes that data and chunks away at it and figures out what's the best model I can create with that data for this purpose. And there should be a few more areas here where that you don't get to go through that process all at once. In fact, you probably have to do a couple of tries and several iterations to get it right. But at the end of the day, then you develop a model that can be used in that particular application. And then after you've delivered that, you need to maintain that, but then you move on to, okay, what's the next highest priority human decision that I can help augment with ML? Again, you go to the work of collecting the data. Again, you go to the work of spinning up the team from scratch. Maybe at this point you get some off-the-shelf tools that can help you with deployment, but ultimately you still have to have a specialized team. Then you get the recommendation, etc. And so we have this very linear and one-to-one process of you have a human decision that you want to be able to augment, and you have to go through the data, spinning up the teams that can create the models and deploying those specifically for that application. So not to be cheeky, but wouldn't it be a lot easier if we could just put all these applications into one ML process and only maintain one ML crack team with one model deployment, with one UI, etc. going on? And I will admit that the model will need to be a bit bigger, the crack team probably a little bit more advanced to be able to handle that complexity. But that would be nice. Could we crack this one-to-one paradigm and go to a one-to-many, where we're designing our ML products with not just one human decision system in mind, but many? That seems like something worth looking at. And I think we're going to see more of this. For obvious reasons, if your metric is number of fires that you want to count, the right side has fewer fires than the left side. So from a business perspective, it's easier to maintain one refined ML product and pipeline than it is to maintain a fragile ecosystem of many, where you have to worry about, did I lose the repo in the last GitHub migration? Did I correctly update the different library packages across all the different models that I've created for my different use cases? So it creates a more stable environment for businesses to operate. Similarly, once it's up and running, then you have fewer models to retrain on a regular basis, which goes to lower cloud bills. And in aggregate, it is a lower development timeline and lower development time to do one massive system than it is to do many ongoing smaller systems. However, it can be a little bit of a tricky navigation to encourage companies to go for the bigger system, because going for the smaller systems is a bit more of a guaranteed bet. It's a little bit more in their comfort zone, and you do have a higher startup cost for that first system that is going to be parameterized out to multiple applications. So in the long term, it is better on the motivation. In the long term, it is better for the company motivations. Alrighty. So what are going to be some extrinsic things that push companies to move in this direction? One big one, I think, is going to be energy. And I think with the cryptocurrency world, we're starting to see that they're hitting the wall on these types of energy problems first. But I think AI and ML is going to be a close follow to the problems that we're seeing with cryptocurrency. Energy is very much going to come into play. Why is energy going to come into play? So data centers, depending on which source you reference, currently use up between 2 and 6% of global electricity, with a growth of somewhere between 1 and 3% every 2 years. And there is a foreseeable path inside of a very short timeline of that adding up to 20% of global electricity. Okay, so we're familiar with handling problems like Moore's law of how do we push chip manufacturing to handle the explosive growth in data and computing worlds. But the energy world is not going to move like Moore's law. It's just physically constrained on what it can deliver. And if you see the right chart there of how much the US has been generating in electricity, yes, we had a massive uptick from burning coal. We all know that, let's just say, we haven't found a nearby planet made out of coal, so that's probably not a long-term strategy. And we've had to invest in these renewable resources to be able to continue to just support our current usage of electricity. In fact, we've actually tapered off a bit in how much electricity we can and do use, with almost a goal of decreasing that. And there's some interesting things in play there, just for folks who want to take a little bit of a deeper look at the energy costs. And I suspect this winter, we're going to hear a few more headlines about energy costs on this one. The blue one there is natural gas. And you can see how natural gas has been compensating for the decrease in coal. And then the other two, where you've got the maroon, that's the nuclear, and the green is the renewables. We're also hitting a point where a lot of our nuclear power plants are aging out. They're designed with only a 50 to 70 year life expectancy, and we haven't built a new one in a very long time. We'll see how well the Gates Midwest endeavor goes. But energy is not something that you can suddenly say, I'd like 20% more of it, please, and could you get that online in the next 5 years? And so cryptocurrency is starting to butt up against this. Of course, is China decided we need to balance our energy usage. Cryptocurrency is now illegal, or mining it is now illegal, and that's become complex. But they've moved that around the world, and one of the ways that they've moved it around the world is, this is a picture of a power plant up in upstate New York, Seneca, where they actually had to refurbish and bring that power plant back online in order to help support the cryptocurrency space. So energy is something to pay attention to, and I think this is going to be a big external motivator for, as we look at how we're using the electricity in the data center for our training and deliverance of models, is going to make us look a little bit closer at how we're using that energy. So you've got business alignment, you've got an extrinsic force that's coming to encourage more efficiency in model development. And then let's go ahead and put it on the table, intrinsic motivator. Reduce, reuse, recycle. I would be remiss for not referencing Timit's work on this. And if you want to take a gander at how much energy your models are using up, greenalgorithms.org is a handy dandy back of the envelope estimate. So in terms of that intrinsic motivator, one of the things I love about data science is that we can pull from many different fields to improve our own field. And on this one, I think we can pull from reduce, reuse, and recycle. And if we use the concept of reduce and reuse in how we're designing our ML products, I think there's some inspiration to follow through on there. Alrighty. Okay. So we've got an extrinsic, an intrinsic, and bottom line pressures. On top of that, I was pretty blown away at how quickly the ML engineering job market has expanded just in the last 10 years. And it's going to become increasingly more competitive for hiring those crack ML teams. And the way that we approach this is not going to be to slow the pace of development by limiting access and those can afford the energy and can afford the expertise, but rather I'd love to see ML democratization after we've done so well with data democratization, for ML to become closer to what a car is for enabling a variety of applications around the world than it is currently as a little bit of a Concorde. I've seen folks use ML for improving politics in Brazil, to improving local gyms, helping folks lower the injury rate. And I think we need to count on an increasingly rapidly expanding application space for where ML should be incorporated. Okay, so we have an idea of let's go from one-to-one to one-to-many, and we have all the motivations, but can it be done? Really, can this be done? Am I just selling fool's gold, or can this be done? Well, let's take a look at a case study of what we did at Stitch Fix. Okay, so a little bit of a side. What does Stitch Fix have to work with? About 150 data scientists with just short of 2 billion of revenue in the spring and 4 million active clients. What do? We allow clients, or we build a relationship with clients to get to know their style, get to understand what they're looking for, match them up to a stylist who has algorithmic support, and then we ship them clothes. And this is a rapidly evolving business model, but at this point in time, they shipped clothes that the client had not seen. Imagine that. Imagine if you just had autoplay on your Netflix every time. So in this, we've got a lot of data, and because we're building up that relationship, we actually have a pretty good understanding of how we fit into what we need to deliver for our clients. And we've got the data all in one place, which is pretty incredible. We've got the data on the client side, we've got the client on the merchandise side, and we've got the feedback of, given that we've seen these pairings of previous clients and previous merchandise, that creates an incredible label data set for how folks are going to respond to fashion. In fact, it does an incredibly good job of predicting the probability of sale of or a match of if we were to ship this to someone, how would they respond to it? Alrighty, so in this environment, because Stitch Fix has its own warehouses and needs to move things around, it has to take bets on new styles. It has to figure out, is this worth bringing into the ecosystem? Is this something that's going to do well enough with my client base? And then it comes into our warehouses and then goes through that process of being matched to our clients. And the timeline, something that's interesting to think about in supply chains is that they don't operate on one unified timeline. They operate on a variety of different timelines for human decision making. You've got everything from way out in the future of how do we think about our TAM and expanding into our TAM? How do we think about our partnerships with different brands, to should I go ahead and fast follow and bring in this dress that just exploded on Instagram? Okay, so we wanted to be able to support that variety of decision making of should we bring these things into the ecosystem. So here's a quick overview of the Style Explorer architecture. And it's very recommender system inspired. You've got a lot of nice parallel processing and acknowledging that we need to bring in different points of models at different times. Okay, so standard architecture there, but there were a few critical decision points that we made in order to be able to use this in as many contexts as possible. One of which was to actually lower the amount of data that we were asking for. When you were to come to Style Explorer with a picture of a garment, to make the requirements of telling us what that garment was is as low as possible. And that might sound a little bit counterintuitive for an ML model where you're like, I want more data. Tell me more. Tell me everything that you know in order for it to increase the accuracy. But we found that by lowering the bar to entry, particularly in the world of fashion, where it is an extremely hybrid space, where you've got folks that have everything from API level transactions of what garments are to folks still emailing and picking up the phone with PDFs of what things are. Being able to operate across that hybrid space by lowering the bar to entry allowed us to consider as many fashions as possible. Another area was that when we originally designed this, we didn't have this in here, but we recognized that, just a second, if you're going to create something that can provide predictions in different contexts, then at the end of the day, when someone's making a complex decision, they're going to want to see all of those predictions. They're not going to want to just narrow their field of scope to just one area. They're going to want to see it in the complete context of, show it to me on predicted for folks in their 20s, predicted for folks in their 50s, predicted for folks on the East Coast, predicted for folks that live in cities, ones that don't, etc. And so by parameterizing the context of different clients at different times, this allowed us to have an incredible parameter in there that allowed this system to be flexible on when it was providing predictions for different, how well garments would do in different contexts. So 2 critical decision makings when you want to get to from that one-to-one to that one-to-many. Lower the bar to entry and parameterize where you think the different contexts of how the decisions are going to be used. Okay, so could we do it? It worked. Fashion is something that I respect the art and the magic behind it, and could we actually use data to predict something so artistically magical? And at the end of the day, we could. And what it came down to was, you can think of it as garments coming together into a variety of characteristics that ML is very good at pulling apart what ladders up into a single garment. And it's used to having seen a variety of combinations come together in the past and how those affect how that garment's going to perform. So here's a sample output of, you put something in and it gives you a nice display of predicted values of how it's going to do in different contexts. And so this was used in, should I buy this garment? Should I onboard this vendor? How will this trend land for our clients? And will this aesthetic learn for our current clients, down to the predictions of, will this aesthetic land for our future clients that marketing is going to do a coordinated effort to? Another thing that we learned in this is the output of the system needs to provide a lot of context for it to be a self-serve environment. That initial use case that you might design for, folks may very well know what a predicted value is in their local domain, and know like the back of their hand, if you say 0.4 or you say 0.6 or 0.7, is that good? But as you expand into supporting more and more applications, providing that context of not just whether or not this is a recommended action or not of buy, don't buy, but also providing a historical baseline of, is this predicted to outperform anything that's been seen in the past, or is this the middle of a pack, or is this very much something that without having that full history like known like the back of their hand, can they just safely walk away from that decision? And another thing that helps with grounding that context is to provide an example of the next best or most similar item that has had a prediction in the past. So providing the context with your predictions at the end of the day allows this to be a much more self-serve environment. So lower the bar to entry, parameterize your space, provide context. And those are 3 design principles that really helped break into that one-to-many. Okay. So also, why this, another thing to keep in mind of, I was a little bit tickled about this because I've spent so much of my career researching computer science theory. I think we're actually getting to the point where we can safely put, yes, there should be such a thing as data science theory on the board. So adding a little bit of theory behind why and how this can work in terms of forecasting is to remember the law of large numbers. So one of the things that we had to do when you're testing as aesthetic is you can't have just one garment that you make a prediction for. When you're testing an aesthetic, you need to test the entire space. You need to sample from the entire space. And with that, you're actually increasing your confidence that you know how well that aesthetic will do, and you're making your decision based off of the overall aesthetic versus one particular garment in one particular garment. Something else to keep in mind when you're doing forecasting is that forecasting has different types of errors. It's got deterministic errors, probabilistic, and chaotic type of errors. And this is a nice little chart for how you can attack that with ML. When it's a known influence, great. Go ahead and code that up, get those features in there, and the ML can act on it. When it's an unknown but measurable, you can bound it a bit, you can approximate it, and when it's unknown and unmeasurable, you're SOL. And knowing when you're making predictions that will fall into different levels of deterministic, probabilistic, and chaotic influence, it's good to know that and bring that into your confidence bounds. So when you're providing these predictions back to folks, they can understand, is this something that they should be very solid on, or something where they're going to need to really leverage that human expertise on how these systems work. One of my favorite examples of a chaotic, unknown but measurable is the effects that social media has on fashion. It's very chaotic in terms of, is this green dress or this blue dress or this particular swimsuit from Big Brother going to take off on social media? It acts like a chaos thing in your system. But when it comes to the evolution of more basics, then you're getting into that probabilistic and deterministic influence, and you can take that into account with being more confident in your predictions. So the other aspect of forecasting is that when you sample more from what you're trying to do in the future, it decreases your error bounds to the point that the predictions you're providing can actually become actionable in the supply chain. If you don't sample enough and you try to make, let's say, company growth targets based off of exactly one garment, your error bounds are going to be too high on that for that to be a meaningful signal to be taken into account for making decisions about the company growth. So the further you're trying to look into the future, the more things that you should be predicting of how they're going to do, aggregate those, and that gives you more stability of what's going to happen in the future for forecasting. Here's another example of being able to take a core model and think about it, parameterizing it and growing it in a way that can support many use cases. There's a lot of different use cases at a company that ultimately come down to some form of clustering. And if we take a step back and not just look at tuning our clusters for exactly the application in front of us, but think of it as, okay, I need to tune clusters at this level, and I'll use that as a constraint for which I tune other levels of the clustering. So I'm building up to hierarchical clustering, then I can support multiple human decisions with one model. So for example, if I wanted to provide user personas to marketing, I can use clustering to get, like, what are the high level groupings marketing should be paying attention to. And if marketing says, okay, you know what, we're going to go after this user persona, then that can break down into more subtle clusters that the supply chain can be more targeted on, and even further down for ML personalization. So instead of, next time you look at clustering as a method for delivering, take a look at, okay, if I tune for this deliverable, if I were to aggregate it or break it out, could I support nearby human decisions on what to do? So I hope that it's a little bit of a slippery idea, but I hope this is stuck with you, that next time you're designing ML to support a specific human decision, take a step back and say, okay, can I parameterize? Can I lower the bar to entry? Or could I provide context in a way that would allow me to support additional decisions? One of the benefits of being able to do that is that that means your subsequent human decisions that you want to support with that model have a lower barrier to entry. And this is a great example of where I think ML democratization can make a difference. So the Elevate program was a Stitch Fix leaning in to helping Black and Indigenous people of color make a foothold in the industry. And I'm very happy to see this program coming to fruition, where we were able to provide the Style Explorer insights back to these folks to help them find that faster product market fit. And working through this process with them, which I'm incredibly grateful for the time that they spent on helping us understand how to help others, is this is what I've learned of working in these tough areas. Create separate spaces for what should be done and how it should be done. That's very counterintuitive in an ML space. Generally, you want those to be as close as possible. When you're tackling tough problems of let's go into something new that has some ethical concerns that we have not understood before, take the time to understand the difference between what should be done and how it should be done, so you're not trading off between the two. Another is to, I know this comes from anyone that's in user experience that has this ingrained in them, but there's a difference between thinking they're helping folks and helping folks. You need to listen to them to learn that. It's okay for academic papers to help people in theory, but for ML, we got to listen. We got to make sure that we close the gap. And the last bit is that I see a lot of management material about how to manage around millennials. Lean into millennials. They have some fresh eyes, and they have something to say. So thanks very much.
June, fantastic. I love that presentation. Great job. I'm looking at this stage chat. I don't see any questions coming through just yet, but if you're going to stay in the virtual audience, we invite everyone to, through the day, connect with June and submit your questions on this chat line, and she'll be able to address all of those. And Dr. June, thank you so very much. We're going to take a moment, and I'm going to bring our next presenter into backstage, and I will bring that one forth at 11:20. We have Navneet Rao standing by. Thanks, everyone. See you in a couple of minutes. Thanks, June.